Hi everyone and welcome to another video, Programming for Data Analytics 621. Today we're going to be looking at exception handling and how it can help you avoid exceptions and problems in your program. So first of all, let's talk about what is exception handling and why we should be learning this. So normally when you're running your Python programs and you hit some kind of error, for example, the most basic one I can think of is you try to divide by 0. When you do that and your program is running at runtime, you hit what is known as a runtime error, which means that as the program is executing, something bad happens and the program raises what is known as an exception. When this happens, your program doesn't know how to continue because this is something that is critical to be able to continue. It's like, okay, this is a really, really bad problem, and unless you know how to handle it, I have to stop. And so your script terminates. And this may or may not be a good thing. It may be a good thing because something is wrong and you don't want to continue with wrong data. Suppose that you're making this massive project and you're running code that's going to take days to run. And in the beginning of it, something is wrong and the numbers are wrong, like you're trying to divide by 0 and your program just kind of ignored it and tried to keep going. Well, everything else is going to be wrong because the data is somehow wrong. In fact, what do you do after you divide by 0? Like imagine you're supposed to divide 10 by 0 and then add 50 to that and multiply times something and divide by something else. Well, the numbers are going to be wrong, right? And so that's the good side of an exception, that it stops your program because something needs to be addressed. What's the downside? Well, the downside is that sometimes these errors are not super critical. The exceptions may be caused by something that is not important or can be skipped and you can keep working. So suppose now you're looking at the same project and it's going to take 60 days to run it. And on day 5 of the project, there's an exception that gets raised because it tried to open up a file, but it couldn't. And this was a file that, while it might be critical for a piece of the project, everything else could have kept going. And now your project just flat out stops. And because it just stops immediately, there's no way to back up the 5 days work that it was fine before it stopped. So the exception just flat out just bam, done. It's like just stops. Like there's no like, oh well, let me just end first or back up what I've done. No, it's just like literally like it just stops. And so that's the bad side too. It's good because it stops when something is bad, but it's also bad because it stops when something is bad versus like, hey, let me back up the work or send a message to the user so they can fix it without me completely just stopping everything. It's not good. Let's talk about, let's say you have a Python script that controls a self-driving car. Your car, sure, if there's an error and it's trying to detect like the camera, computer vision, and it's trying to detect that there's a pedestrian or something, you want the car to stop, right? If the car runs into an error where it doesn't recognize something that it sees and it raises an exception, you don't want the program to just flat out terminate, because like that just means it shuts down the autopilot immediately and maybe doesn't even give you a warning. It's just like bam. It's just, imagine like the car just shuts off like as you're driving. Well, you lost control of the car now and you might actually crash. What would be better is if it hits an exception, the car should save the state of where it's at so that it can know what caused the exception and give some debugging information, some telemetry. It should also activate some protocols to terminate in a more elegant way, such as like, well, maybe I should stop the car, give a warning to the user, put him in a safe position and then shut down the autopilot. Or maybe I should ask the user to help me out so I don't have to just stop. Like, hey, take over for a second, or can you tell me what this is? So that's the way that you handle an exception. You shouldn't just completely ignore it unless you know that it's safe to, but you shouldn't just let it completely just destroy what you're working on and lose days of work. So how do we achieve that? Well, you will notice that, let me just start out by showing you an exception and what that looks like on Python. And I want you to notice something about the exceptions, okay? So I went ahead and wrote a little bit of code ahead of time of an exception that we're going to see. So I'm just going to move that down for a minute. But I would just show you the most basic of exceptions, which are I'm going to try to divide by 0. Okay? So I got a variable, and I'm going to take the number 5, and I'm going to divide it by 0. Okay? That's all my code's going to do. In fact, I don't even need this importing stuff. This is just like cleans the screen. But one line of code, bam, the program crashes. Now this is on the IDE, but if I was running this on a terminal, like this, you get the same thing. Traceback error, 0, division by 0 error. Okay? So you get this exception. And more importantly, your program basically just stops at that point. So like if I have a line of code beneath it that says, you know, code, and I can have a line of code above it that says, you know, before. If I run this, I print this line out, I get to the exception, but bam, the program just terminates at that point. You get the exception, you get some output, which we'll look at carefully, but then you never get this line of code printed because the program literally terminated. And if you do this on the terminal, same thing. You get the before, because that's a line above it, then you get the traceback error, and then you get nothing. So as you can see, the program just flat out stops right there and then. Okay? So let's look at the error carefully. Exception has occurred. It gives you the name of the exception. It gives you a description of the exception. That's pretty nice on Python's behalf. And better yet, it tells you exactly where the exception is in your program. As you can see here, it says it happened on this file, which is located here. It's line 6 of this file, and this is what that line is so that you can see it. So now you're like, oh, well, looking at this and looking at the exception name, you can make the conclusion as to why that happened. In this case, because, well, I tried obviously to divide by 0, right? Now, this may not be so obvious. For example, let's say that I am taking a value from the user. And then I make a division by that value. So in this case, you know, you might be like, well, ahead of time you should have seen that. Well, in this case, I can't really see that ahead of time. I run the code, I enter a number. If I enter a number that's not 0, it runs fine, right? You can ignore the bottom stuff. But it runs fine, and you can see the word code printed. But if I run this again, and I put a 0 here, then I get the same error, and of course this time it says 5 divided by div. So this may not be so obvious as to what happened, but hopefully you see that it's division by 0, and you see that there's a division happening in that line, so it must mean that div must contain a 0, right? Or at least that is my guess, because what else could go wrong? So if we look at that same piece of code on the terminal, we can see that it's also saying traceback. Well, actually, I don't think the one says traceback, it says exception. But here it says file, it says the line number, the file name, the line itself, and it gives you the exception name. It just doesn't say the word exception. But for all intents and purposes, it's a traceback error, which you can think of it as an exception. Everything else is the same. Okay, so this is an exception. Now, what do we do to stop this from breaking our program and just completely stopping it? And for that, we have what's known as the TryAccept block. In other programming languages like C++, it's called the try-catch block. So, but most programming languages have some form of exception handling. And so, what we want to do when writing code is we're going to be using the following 2 keywords. We're going to be using the word try with a colon after it, and we're going to be using the word accept also with a colon after it. And the way this is going to work is when we try, we're going to write some code here, and this is the code that we're going to run. And if this code raises an exception, such as division by 0, because it's inside of this try block, and the try block is tabulated, just like your if statements and for loops, indented, when it does hit an exception there, it's going to stop what it's doing. So let's say that within here, this is all normal code, and then bam, it hits an exception right there, and then this is other code. When it hits this exception, it's going to immediately get out of this try block and go into the accept block that is after it. And you should have an accept block after it. Now, this accept block is going to catch that exception if it happens, and then it's going to go ahead and execute this code, which is like your exception catching code. This code is only going to run if an exception is raised in the try section of your code. So for example, if you're running your code like on let's say that this is your division by 0, okay? So this is your 5 divided by var. If you're running your code and there is no exception, let's just say you have some code above it, this code is going to run. And then afterwards, there might be some other code to run as well, okay? So when you're running your code, you're going to be running this code. You're going to enter the try block. And as you run this code, let's say that you don't have an exception. When you finish the try block, you immediately go to the code after the accept block. So you do not touch or run any of that code. Let's say you're running the code and this time there's an exception. So you're running your code, you start the try block, and then bam, you hit the exception right there. You do not run this code or this code. You immediately go and start running the exception block. And when you finish running that, then you get to run the rest of the code. But as I said, the code does not terminate. Okay, you can call like exit or something here to terminate the code if you want, but the code does not terminate. Let's see what that would look like if there were no exception handling in this code. So you'd have the code before, you have the code after, and then you have your code that was in the try block, but there is no try block in this version. So this is your code before you knew exceptions. So you're running your code in the normal version. If there's no exception, then it'll run through it and then run afterwards. So it'll be the same case scenario as if it was with exception handling involved. Where it's going to make a difference is if you run code that has an exception. Bam, you hit the exception right there, and guess what? The program terminates and you never get to run any of that code. At that point, we have termination. And you get the error that says exception raised, blah, 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 and you get all the warnings, and the program, like I said, stops. So, what do you want to usually do here in the exception handling? You want to do things like back up your code or back up any work in progress that you've done. You want to get some telemetry on why that exception happened, such as print it to the user. You already are getting a little bit from Python, like we saw traceback error, you're getting the line number, you're getting a description of the exception, so you're getting some information. But it may be useful to get additional information from other parts of your program. So in addition to backing up, you want to know. And the reason why is because you want to fix that. If this is a problem with your code, this is what's going to help you fix it. So you want to be specific and thorough with this stuff. Write it to a file, do things like that. Finally, and this is up to you, you want to either push ahead, do any modifications needed to handle that exception and keep going, or you want to elegantly terminate the program. What does that mean? Suppose you're playing some video game and it crashes. You want to have a thing that says, hey, the program has crashed. Would you like to send a report to the developers? Please press here. And if they do, it sends it. And then, it cleans up any memory stuff, cleans up whatever it needs to do, and then terminates. That's a nice way. The not nice way is you're literally playing and then bam, it just 1 second you're in, next second like you're on your desktop, right? So just an example with the game, but it can apply with anything. Let's think about more of like a data analytics point of view. You're probably analyzing data, you're trying to get the average of something, you're summing all of these things. You may want to back up that sum before you just flat out terminate so that you can pick up right there on the next run. If you're running again your program for 60 days and you've run it for 5 days before the exception gets raised, you want to back up that 5 days worth of work so you don't have to oh snap, okay, I fixed the exception, let me rerun the program and have to wait 5 other days. You don't want to do that. You can back up your data, fix the program, pick up right where you left off from and lose only the time it takes for you to fix the exception, basically. And well, to be there to actually see that it happened and then fix it. Okay? So this is kind of the most basic version of exception handling. Let's look at an example, like I said, that I had here when it comes to files. So this one, of course, is just for division. Oh, well, here, let me just write to you the exception. So I'm going to go ahead and put in my try block, division, and then I'm going to put in my exception, you know, exception raise or something, division by 0, and print out the value of bar so I can see that it is 0, and so on. Now, here's something that I want to show you. If I just write exception like that, okay, I can show you this too. So what I did here is I actually raised an exception because I meant to write div here. I wanted to show that the contents of the div, not bar. But something very interesting happened here that actually kind of brings something else up. So I was gonna write, you know, in fact, here, let me show you the right version, and let's come back to. I want to talk about this because this is like exception inception, basically. So I meant to write division there so that we can see it. So, you know, if I write in 0 here, then it says division by 0 and print out the 0. So you can see the program does not terminate and it does not raise an exception, right? So this is catching all exceptions, and I will come back to what I mean by all exceptions, okay? But let's go back to what I had before, and let's read that error because it's actually pretty neat. So enter 0. It says name bar is not defined. During handling of the above exception, another exception occurred. So yes, it is very possible that when you're doing exception handling, in your exception handling code, so the purple one there, you have an exception itself, and then that's bad. So what do? Well, you could put another exception handling block inside of your exception handling block to be extra safe. And by the way, this might be like, well, this is, you know, this was an accident, but this may be more common than you think, because when you're handling exceptions, things are inherently broken, and you don't really know why, because if you did, you wouldn't have coded that exception. You would never you wouldn't just have that error in the first place, right? So, I mean, sometimes exceptions, you know, are out of your control, like you're opening a file and it's not there. But other times, exceptions happen and you just don't know why, but you do have your TryAccept block in case it does happen, so you can then investigate. So it's not uncommon that you run up to another exception. So you have to be careful about that and be very careful when writing exception code to make sure that this kind of thing doesn't happen. But, you know, let's catch the exception inside the exception. So I would put a try block here and say, oops, again. So now we can see that we don't crash. We have our exception code being run. We don't see the try print part here because the way the code is being interpreted, it's going from right to left. So when it's running this, it runs this first before it assigns bar. So because this generates an exception, bar is never created. And that's why this line of code was causing an error, because bar did not exist. Now that error itself is being called by this exception, which is just saying whoops. Okay? As you can see, it's a mess, but you know, I guess this is the best way. Now, what happens if you raise an exception here? Or actually here? Like, I don't know, potato, this variable doesn't exist. Well, let's see that happen. It says, during handling of the above exception, another exception occurred. During the handling of that exception, another exception occurred. So we got like exception handling inception, basically, which is what we kind of expected to see. So Yeah, don't do that, hopefully. 2 layers, probably more than enough. Otherwise, something really bad is up with your code, or you're just being careless, okay? So before I show you the file issue, I want to point something out. Right now, we are just writing except. So we're catching any exception that gets raised. So whether it's a division by 0, or you have a file issue, or in this case, a variable does not exist, you're catching all exceptions. It's a catch-all, as they call it in C++. I guess except all will be named in Python, maybe. You may not want to do that. You may want to say, okay, if you have an exception on this type of error, then do this. If you have an exception on that kind of error, then do this. For example, if you have a division by 0, that's really bad. We want to actually save and end. But if you're trying to like open a file up and that file is not found, then if it's just like some log file or whatever, no big deal. So if you want to be able to choose between the different exceptions raised, what do you do? Well, what you do is you name the exception that you want to catch. So, for example, when you run this, if we get rid of all of the exception code, or here, let's just write a line of code up here that says that before the exception so we can see it. Oh, I keep forgetting how to put a 0 in. You will see that you get the name of the exception right here. This is actually the type or name of the exception. And that is the same thing you would see on a terminal if you were to run that. 0 division error. That's a very useful name to know because you can use that name to catch only that type of exception. So for example, if I want to catch that here, then I can write 0 division error. Now you'll see that it auto-completes. Python's nice like that. So now this exception code is only going to be catching division by 0 exceptions. So if for some reason you have another exception here, such as saying, let's say car is going to get some variable that doesn't exist called potato. That's a different kind of exception. Let's see what that exception is called. Oh, well, we gotta put this inside the try block, so I'm gonna get rid of that. Put 0 there. Oh, well, okay. So right now what's happening is the division by 0 is raising an exception there, and it's immediately going to this, so it's never running this code. This is something that can actually happen too. So you could have bad code that never gets executed, whether it's because it doesn't go into an if statement or because an exception gets raised, and you never notice it until actually you see it. So it's always be careful about that. In this case, we don't want to raise this exception, so what I'm going to be doing is I'm not going to give it a 0, I'm going to give it like a 2. So bam, we hit the exception for name error. And you can see that that exception did not get handled by our exception 0 division error. If we went ahead and remove this and run it again, even if we don't put a 0 here, well, if we put a 0, then it handles it because we got that. But if we don't put a 0, it still handles it with the same exception handling, division by 0, right? So what do? We put 0 division error there, and we run it, and so now we get the exception. So what we can do now is if we want to handle that in a different section of the code, we can go ahead and say something like except, and then put that exception name, which I believe is name error. So I'm going to say for that one, bar doesn't exist, or variable doesn't exist. So we're going to confuse it with actual bar. So now, if I put a 2, we get the exception from variable does not exist. If I put a 0, we get the exception from the division by 0. Or do we there? Actually, I didn't see it. Hold on. 0. We are getting a whoops being raised. Oh yes, because we are raising the exception here. That's exception inception. So here, let me put that back to where we want it, so that we can actually see that, because it's going exception, 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 basically. So there we go, division by 0, right? So now we have a try block and we have 2 except blocks. So if we want to update our little diagram that we were doing, what we're essentially doing is take this. So now we have one accept block, we have a second accept block, and that accept block is related to the try block. Okay, it's still catching from that try block, but instead of running this code, there's some different code here. Otherwise, why would you make them different, right? And so now this is catching the name error exception, and this one's catching the division by 0 error. And so now, if anywhere in this code there's a division by 0 error, then it's going to run this code here, and then it's going to go to here. If there is code from name error, so a variable is not defined, then it's going to run this code and then run this code. Okay? So you want to have a try block, and you may want to have multiple exceptions. However, my recommendation is this. If you are going to have multiple accept blocks for each kind of error, I still would encourage you to have a catch-all at the end of this, just in case you missed any other exception types. Of course, you can just let it be, and if that does happen, let it terminate so you can get what kind of exception that is. But remember, you're going to lose everything. So, your choice. But that's just my recommendation. It's like your backup, you know. You have your front line and you have your backup defenses, basically. So what that would be like would be if I put accept here. Something else happened, basically. So now, you know, we have a variable doesn't exist, but if we get rid of that, we're not going to get any exceptions. Oh, we have, well, I typed 0, so of course there's an exception. Type a 2 there. No exceptions, but now let's throw in other kinds of exceptions. So let's do, let's try to concatenate, or let's try to, let's try to concatenate a string. So we're going to have a string, so we're going to call this S has the word hi, and I has the number 22, and we're going to say S plus I. Something else happened. Now, you don't get to see what the details are of that exception, unfortunately, because you don't print them out, but you know that something happened, and at least the program does not terminate. Okay? So, what if you want to see what's up here? What happens, basically? Well, I believe there's a way, in C++ there is, and I'm almost sure in Python there is as well, to catch the exception name details. Let me check documentation. I think you could do error. I think it's just error. Or E. Might be E. No, that's a NumPy thing. Maybe. Let's try that. Oh, darn it. Type error. hold on. E. Ah, okay. It's exception. Exception, there we go. So if I do this now, oops, what was I doing here? Code. There we go. There we go. Okay, so exception will be your catch-all for the class. When we get to classes, that'll make more sense what I mean by class. But now, if we want to print out like details of this, then we can say something like follows. So we can say exception dot print, or actually no, print exception. So you can see here that we are getting the type of the exception, which is just called exception. If we do aliasing like that, we can make it shorter, and also we can see more details of the exception. So in this case, I can actually see similar information to the stuff that I would have gotten if I just left the exception out there. So it says can only concatenate string, not int to string, and there's probably more information on that E. Let's see if that will work. So let's try it just like that. Okay, so let's try printing that. If it's going to give us an error. Here we go. So we get traceback object. So we're getting a location of the object. I believe there's a what function that you can also use. Or type, I think. Let's try type. I might just say exception. Oh no, here we go. Type error. So yeah, there we go. Okay, I like this one. So I'm happy now. So when you do your catch-all, you can use exception as E, and then you can go ahead and print out the details of the exception by just printing out the variable. You can see here that we get the same kind of error we would have gotten on the terminal. And then if you use the type, you can get the type of the exception, so that in the future, if you know that this is a kind of exception that is being raised for some reason, then you can go ahead and write another accept block with that specific type of error so you can handle it better. Okay? So that's very useful. One more thing about exception handling that you don't really use, but I guess it's a thing in Python, is the word finally, the keyword finally. So the keyword finally in Python is like just code that will always run regardless of whether you hit an exception or not. So I guess that's kind of nice. I don't know. You can see here the word finally being printed, and if we don't have an exception because we don't have this error here, then you still get the word finally printed, which does the same thing as code. So that's why I'm not, it seems a little bit unnecessary, but it does exist. All right, let's try to write an exception by not indenting this correctly. Let's see what happens in that case. Indentation, oh, it happens, well, it's inside my try block, technically. But it's still, yeah, it's like, well, maybe if I do this way. Nah, it's just an error. How can I catch that? How can I catch that? What if I manually try to catch it? Yay. Nope, not catching it. Maybe if I put this in another try block, maybe it'll catch it. I gotta tabulate everything here. There we go. Where's it at though? There's no yay printed. Oh, well, I haven't broken the tabulation yet. Nope, I can't get around that. That's probably a good thing, because you probably don't. Like, you should be using exception handling for runtime errors, not something that you just coded really badly anyways in the first place. So, yeah. Okay, so that's your basic exception handling. And the only other example that I had was with a file. So let's look at this one. So one of the kind of popular things that you may run into with exception handling is not necessarily that your code is wrong, but just something in the system is wrong. So suppose that I want to open a file. Now I have a file here called COVID-RI, and I have the wrong file name. Okay, so if I try to open it without the exception block, then you are going to be getting an exception. So just try that by putting it up here. Put a number in. Exception has occurred, file not found error, because yeah, it's not found. And so what do? Well, first of all, I put it in a TryAccept block or TryAccept block, and I use the file not found error, and then, you know, at least I don't crash. Now this might be, again, something that you don't necessarily have to terminate your program on, but you might just skip it. You may try alternative file names in the except section and put that in the try block too, in case those don't work. An example of this is like, suppose that I had a bunch of files, and I have all the code files here from 1 to 23, right? Let's say that I want to open them all, but I don't know how many there are. So I say just try to open files 1 to 30. So, you know, I run with the loop and I try to open them all. And when I hit one that doesn't exist, I can just use the exception handling as a way of stopping that count instead of just crashing. So let's go ahead and write that really fast. We'll wrap it with that. So I'm going to say with open, and then I'm going to put this in the for loop. You know, for I in range of 1 through let's do 25. Okay, so within that range, I'm going to try to open the file, and I'm going to know that it's called the I, and I need to convert that into a string, otherwise I'll get that exception. And then I need to concatenate that with the file ending, which is py, right? And that's going to work for files 10 through 23, but not for these initial files. But I don't know that at this point, so I'm just going to try to do this naively. But, you know, in this case, it's not as bad if they don't open correctly. So I'm going to say I'm just like some file that I'm opening. And when I open it, I'm just going to say open file, and then I print out the file. So that's stri plus py, okay? Of course, if I want to process the file, maybe load it into a variable, I can say f, and then just append the entire file there. So f append file or something, okay? And so now my accept is that the file is not found, and if it's not found, I'm going to say could not find, and then I want to print out what that is, right? So here's we can try this. I don't know if it's going to work with the variable scoping rules, but we could try to print out the file name by just copying this. See if that works. Maybe that'll raise an exception itself. And then we still have our code afterwards, just so we can see that it prints that out, okay? So we'll call this like end. So open f append. All right. Run this. And it says could not find 1py end. So right now, you know, we try to open one file, but then it gives up. That's not the logic that we wanted, because we wanted it to keep going, to keep trying to opening other files, right? So what we need to do is we need to actually move the try block inside the for loop, so that it runs every time the for loop is run, but when it gives up, it keeps going with the for loop. It prints out our error message, but then it keeps going. Like that. Okay, run it again. And so now it says, could not open files 1, I said fine, but it should say file, but either way. It says 1, 2, 3, all the way to 9, and then it opened 10 through 23 and did not open 24, right? So this is an example of something where I want to load a bunch of files, but some of them may not exist, but I don't want the program to terminate. I want to open as many as I can. And I did, and I loaded them all into F here, which I don't use, but I could. So, you know, if I just want to print out what the length of that is, I can. That's a nice little use of that. So, length of F. I gotta get rid of this input thing. It's bothering me. I have to type 14. So I could open basically 14 files. I think that's what that says, yeah? Is that count off by 1? Possibly. But no, because it goes from 0. Yeah, that's right. So yeah, okay. Maybe in my exception, I would to try to open the files by putting a 0 in front of it, because I know that doesn't work. So like with the files that are single digits. So I could put inside my accept block, I can put in the try block. Before I print out that could not print out thing, I could, or I can still print it out, but I can try afterwards. Before giving up completely on this file, I'm going to try to open it by adding a 0 in front of it. So I'm going to put 0, and I'm going to concatenate that. And I'm going to try that. And if it fails, with the same error again, I'm going to say print, tried adding 0, but still failed, giving up. All right. And I'll print the file name again, just so that I know which file, giving up on this file. Okay. Let's put that on. 2 different lines. There we go. It looks a little nicer. Okay. So, oh, come on. 1, 2, 3, comma. There we go. Let's run it again. This time, let's just please get rid of this input thing because it's annoying. So it's hard-coded to 22, so we have to keep having to enter a number every time we run this. And now we can see that it says could not file 1. Could not, oh, I see. I meant to say could not find file. That's okay. But then we see that it opened it anyways. Opened it. So as you can see, it's good to go. I don't really need this print statement anymore though, because if the other thing fails, then you know, we can just try it. Or we could leave it, doesn't matter. But the point is that we're able to open all the files now without exception handling, with the exception of 24 because it really does not exist. As you can see there, try adding 0, still failed, giving up on 24. So you can see it opened that. Now, of course, if we made this range up to like 29, then of course those files don't exist, so it gives up on those. But you can see that it still successfully read all 23 of them. So there's just a nice little trick on exception handling. There's probably better ways of doing that, but you know, it's just an example of how to use this. In my experience, when I had benefits of using it is when I'm connecting this to a SQL database, and basically I try to make a query, and I assume that query has some data back to it, and I try to run some processing on that data. But if that query returns no data, then that could raise an exception. So I catch that. Or for example, if I send a query and it just raises an exception flat out from the SQL code, instead of just having an error, then I process that as like, well, that returned nothing, or that table doesn't exist or something, and does not just flat out give up and terminate my program. Which again, you don't want to do if you're working on the program that is going to take days to run, and you want it to at least run all the way. And if it fails in something, set that aside, keep going with the rest, and then you can work on that later so you don't lose your progress. So there we go. Let's just make sure we didn't delete all of our files. They all seem to be intact. It's kind of risky opening our own older code and, you know, accidentally put a pen on this and write and delete all files. But nope, we did okay on that. So I believe that is all that I have to say about exception handling. There is the raise keyword, which I didn't mention. I guess I could mention it, but it's kind of specific to like on its usage, so that's why I don't really popular. But I guess I'll show it to you very fast, just in case that you see it. If you write the word here like raise, you can see exceptions occur, no active. No, let's just do that. Let's do that somewhere else. Let's do it in, let's do it here. So let's switch this to 0, so we erase that division by 0 exception. And here, let's just raise and say, oh, well, that's gonna catch it with the other exception handling. Let's just write some code here. So let's just say try, let's just say var equals try divided by 0, and then we got our exception that catches that division by 0. So division by 0 error, and then you say bad things happened, and then you say erase. Okay, so let's see what happens then. So in this case, when you ran this, we still get this exception that terminates the program, but we can see that it says division by 0. Okay? Right, I'm gonna run it again actually. So not the, did I not put that? Why is it not raising the mind? It should be printing this as well. Oh, we can see it being printed here, actually. Yeah, huh. Let's try that without. Okay, so without it's going. So with raise, I guess it's probably because I'm using the terminal that is throwing me off. By the way, this became full screen. I did not notice that. Why did it become full screen? Very weird. But yeah. So basically what happened is when you run it on the terminal, then you will get the exception, but then it'll also ensure that this actually stops the program. So it's a nicer way if you want the program to still terminate. But you don't really use it, so that's why I'm iffy to mention it. So yeah. Switch over to this. I think I broke the VM, so I can't show you that message. Give me a second. VS Code, why are you doing this to me? All right, I managed to at least tap to a different window. So not the one I wanted, but there we go. All right, so Python 3. So here we go. All right, so you can see here what is happening is this. When you raise your exception, or when you have your try block, you see that we're doing the division by 0. It catches it with your accept block here. You print out what's happening in there, so you're running the code in there. But when you say raise again, what happens is you like reactivate the exception. So like, let's say that you still want to have like a division by 0 exception being raised to the user. But before that, you want to do some backups. So instead of having your own like exception handling code that like nicely, elegantly tells you something bad happened, etc., maybe here you want to print out some information to the user and then raise the exception to terminate the program. You can do that. All you got to do is just type in raise, and you put raise inside of a TryAccept block so that it re-raises that exception that it caught. Okay, so it's like re-triggering the exception. This may also be useful if you're working on a library and you're trying to like send this back to another function. If you raise an exception on a function and it doesn't handle it, then in like programs like C++, it sends the exception back to the original callee, and that can handle it too if that's in the try block. So there's a lot more to exception handling, but I think that for this introductory level, what I've done is enough. So that's why, raise, I'm mentioning it in case you see it. Now you at least know what is happening with that. But I think you should just stick to your basic TryAccept blocks and remember to list the type of exception at the top here so that you can catch those specific exceptions, or also to have your general accept block to catch everything else. And if you want details on it, you can use this syntax as well. Okay? So with that, I'm going to go ahead and wrap up the lecture on exception handling. And hopefully this helps you handle all of your issues and exceptions so that your code can run very smoothly. Okay? Thank you for watching and have a great day.